Hello everyone, welcome to Eduxcite classes. Now we are moving from A.3 to A.4 rigid body mechanics. Those who have not watched my previous video, please go and click on this icon. The PDF is available on this link and the link is also given in the description below. Okay, so if you click on this YouTube channel, you will get all the playlist related to all my previous video, and if you click on the WhatsApp icon, you can chat me anytime, anywhere, but please avoid the odd hours. Okay, so today we'll discuss the first part of A.4, which is related to the kinematic of rotational motion. So I will give you some time to pause the video and you can solve with me and you can check your answers, and if you have any doubt you can clarify using the video solution. So let us start today's session. These are the formulas that are given in the data booklet. These are quite similar, which you can resemble with the Suvet equations, right? So if I just want to compare, this theta is representing the displacement, angular displacement is theta, as is your linear displacement. So you just have to replace, you can say whatever the Suvet equation, s is replaces by theta. Similarly, u is the initial velocity. Here it will be angular initial velocity, which will be denoted by omega I. Similarly, v is your final velocity in Suvet equation. Here it will be omega f. Acceleration, linear acceleration was denoted by a. Here we have uniform angular acceleration, which will be denoted by alpha, and t remains t only, time. So if you replace, if you know the Suvet equation, you can just compare it with the rotational kinematics equation with these variables. So rest all remains the same. Similarly, the same applies with respect to your graphical analysis. So we know that in a graph of theta versus time, so if we compare this with displacement versus time, the slope was given by velocity. Here it will be angular velocity omega. Similarly, in a graph of angular velocity omega versus time, the gradient will give you the angular acceleration, which is nothing but alpha, and the area under the angle, area of the angle turn is the the area of angular velocity versus time will give you the angle turn, that is the angular displacement delta theta. And if a graph of angular acceleration against time is given, the area is the change of angular velocity, that is delta omega. This is nothing here. Okay, so I hope it is quite clear. Now there are various confusion among the student about the different types of acceleration. Now till now what we have done, we have in this unit we will discuss about more about angular acceleration, that is known as alpha. You have learned about centripetal acceleration in circular motion, and tangential acceleration or linear acceleration is one and the same thing. So guys, do not get confused about alpha or your centripetal acceleration or your tangential acceleration. They have different meaning and they have different uses in it. So if you look at angular acceleration, it is the rate of change of angular velocity. Centripetal acceleration is the acceleration towards the center when an object is moving in a uniform circular motion, whose formula is given by v square by r. Whereas tangential acceleration is your linear acceleration, which we have already discussed in your Suvet equation, which object is changing its speed along the circumference of a circle. Now because the object are moving, so along this, which is given by alpha r. This is the relation between angular acceleration and linear acceleration. Okay, so a constant angular velocity means there is a angular acceleration is 0, because if there is no change in angular velocity, then there will be no change in angular acceleration. But tangential acceleration will also be 0, because if this is 0, then this will also be 0. There will still be centripetal acceleration, because still the object is moving in a circle. When an object is moving in a circular motion, one acceleration will always be there. That will be your centripetal acceleration. So towards the center of the rotation. Okay. Okay. So now if you look at this particular A part, omega x will be equals to omega y. The reason being they both cover same angular displacement in time t. So because they will rotate with same angular velocity, so they will swap equal angle in equal interval of time, and that is nothing but the omega is defined by angular displacement over angular time. So they both have same, so the ratio for omega x over omega y will be 1. So I hope it is quite clear. Now for B part, Vx and Vy. Now Vx and Vy is nothing but your relation, that is omega into r. Linear velocity or linear speed is equals to omega times r. So Vx will be omega times r and Vy will be omega times r by 2. Now if you do Vx over Vy, it will be omega r over omega r by 2. So that will give you 2. So that will be your answer for question number 1. I hope it is quite easy. Now pause the video for question number 2 and solve. Okay. Now if you look at this particular A part, calculate the angular acceleration. That is what we have to calculate, alpha. Now it is given that it started from rest. So can I say omega I is 0? So omega f is given us in 240 revolution per minute. Now this is very important from this particular topic, how to convert your revolution per minute into its SI unit, that is radian per second. Now for that, always remember in one revolution how much angle is swept. First let us convert this into second. So 240, in 1 second it will be this much. 240 divided by 60 will be the revolution per second. Now in total it takes 2 pi to complete this in one revolution, so the angle swept in per second will be this much. So if you do this calculation, I have already done the calculation, you will get something around 25 radian per second. Now we know we have omega f, omega I, and we know alpha is nothing but the change in, so this will be and this happens in 4 seconds, right? So omega f minus omega I by t, which is 25 minus 0 upon 4. So this you will get 6.3 radian per second square. That is the unit for angular acceleration. I hope it is quite clear. Now if you look at the B part, radius of the wheel is 34 centimeter. We have to calculate the linear speed of a point on the circumference of the wheel. Now we know that V is equals to omega r, so we will use this relation. Similarly, V will be omega, as we have already calculated, which is 25, and radius is 34 into 10 raised to power minus 2. Now if you solve this, you will get the linear speed, which is the speed of a point on the circumference of the wheel. So that you will get something around 88.5 meter per second. I have already done the calculation, you can also do in your calculator. So this will be your answer for your B part. Now if you look at the C part says that outline how the centripetal acceleration of the point on the circumference of the wheel varies with time. Now if you look at this particular omega will increase, that will increase the linear speed as well. Now as the linear speed increases, you can say as the V, that is your linear speed is increases, your centripetal acceleration is V square by r. So this also increases. So I hope this is quite clear. So this is the centripetal acceleration that will also increase with respect to time. Here guys, do not get confused about the centripetal acceleration and your angular acceleration. Angular acceleration is the complete whole acceleration of an object which is rotating, whereas centripetal acceleration is the acceleration due to circular motion of each individual point on the circumference of a fixed radius. Okay, now pause the video for question number 3 and solve. Okay, now if you look at the A part, we have already given the angular velocity initial is 30 radian per second, Okay, a constant deceleration of is given 0.45 radian per second square, and the top of falls over an angular velocity which has decreased to, so omega f is 5 radian per second. We calculate the number of rotation for the top which makes it before fall over. Okay, so how many number of rotations? So for that, first we have to calculate the um, angular displacement, and then using the angular displacement in that particular time period we can find out the number of rotation. This is quite common. So here we can directly use v omega final square equals to omega initial square plus 2 alpha times t, sorry, 2 alpha times theta. So this is 5 square, this is 30 square plus 2 times a minus 0.45 because this is decreasing times theta. Now theta comes out to be, if you solve this particular equation, this will come out to be, I have already done the calculation, theta comes out to be 970 radian. Now this is the total angle swept in this particular situation. Now we have to do in the number of rotation. So for that I can do in one rotation 2 pi. So for number of rotation I can say it will be theta upon 2 pi, which is 970 upon 2 pi. This comes out to be nearly equals to 150 revolutions. So the total angle divided by 2 pi will give you the number of revolution, because in one revolution 2 pi radian has been covered. So if we have 970 radians, so the total will be 970 divided by 2 pi. Okay, now the B part, the time it takes for the top to follow. So you can directly use, that is omega f equals to omega I plus alpha into t. So this will be 30 plus minus of 0.45 times t. So the time t comes out to be 56 seconds it will take to for the top to fall over. So this will be your answer for question number 3. I hope it is quite easy. If you have any doubt, just comment below. Now pause the video for question number 4 and solve. Okay, now if you look at the A part, what I can say is a constant angular acceleration is 4.7 radian per second square. That is fine. Angular velocity we have to find, final angular velocity after time t we have to find out, and that too in revolution per minute. Okay, this is quite good. Time is given to us as 20 seconds. So first of all I will find out in radian per second, and then accordingly we can find out for revolution per minute. How? Just pay attention. So first I can directly use, and it is also starting from rest, so I can say this is 0 radian per. So I am using f omega I plus alpha t. So this will be 0 plus 4.7 times 20. So omega final comes out to be 94 radian per second. I already done the calculation. Now this is in radian per second. Now to convert that into revolution per minute, how many rpm? In short we called it this as rpm. What we can do is we can find out the total radians that has been swapped. So what we can do is in 1 second, if this is the case, so what we can do for angle swapped in 60 second, that is 1 minute, in 60 second will be 94 times 60, which will be equals to 5640 radian, right? Now if we want to do this per, so this is radian per minute. Okay, this much is the radian covered per minute, and if to convert in revolution, one revolution is again, so I will divide 5640 upon 2 pi. So if you do this, it will be 897.63. so nearly we can say in angular or you can say angular final angular velocity in revolution per minute is 900 revolution per minute. So this will be your answer for part A. I hope it is quite clear. Now the number of revolution of the drum makes during this time. Now we have to find out the drum, how many revolution does the drum makes during this time. So we can directly use, this was the A part. Yeah. So B part I can say is theta is equals to omega I t plus half alpha t square. So this will be 0 because it is starting from rest. So half times of 4.7 times 20 square. So this will give me in radians. So this comes out to be 1940 radians. So that too in revolution per minute, I can say 940 divided by 2 pi is something nearly coming out 150 revolutions. So this will be your answer. Always remember, when to convert revolution per minute, find out the total angle swept in the given time frame, or if you want to find out for angular velocity, find out the angle swept as per that angular velocity and divide by 2 pi, because one revolution is equals to 2 pi. Okay, so that's the way. Now question number 5, quite easy, just pause the video and solve. Okay, so A part, what's the angular velocity at the end of 5 seconds? This is quite easy, guys. This is omega I, this is alpha. So omega f is equals to omega I plus alpha into t. So this is 0 plus 5.2 times 5. So omega f comes out to be 26 radian per second. So this is your answer for the A part. Now the B part, calculate the total angular displacement in this time. So if I want to find out angular displacement, I will use omega t plus half alpha t square. Omega t is 0, omega initial is 0 plus half alpha is 5.2 into 5 square. I have already done the calculation. This comes out to be 65 radian, guys. Quite easy. Just you have to use the Suvat equation in the same manner we did it in my previous video. Now the C part is how many rotations does it complete in 5 seconds. So just theta is 65 divided by 2 pi. This will be something around 10.345. So how much it completes? So the completed revolution is nothing but 10 revolution. So that will be answer for the C part. Now after 5 seconds, the accelerating torque is removed and we'll deaccelerate at a constant rate to become stationary again after 18.2 seconds. Calculate how many rotations are completed during this time. So again, for this particular time, we have to find out the total angle swept and then we will divide it by 2 pi. So now we can again use the direct equation of theta is omega I plus omega f, because we know both the angular velocity into time t. So omega initial is 26, because from here it is deaccelerating and finally it is becoming stationary. So this will be 0 divided by 2 into time it takes is already given in the question, which is 18.2 second. So this is 18.2. So if you solve for this, you will get something around 37.656 radian. Okay, sorry, this is revolution, so this will be 236.6 radian, my mistake. So this is the angle swept in 18.2 second, total angle swept. Now to complete for revolution, what we will do is theta by 2 pi. So 236.6 by 2 pi gives you 37.656 revolution. So the completed revolution is 37 revolution. So this will be your answer for option part D. Okay, I hope it is quite clear. Now pause the video and sketch the graph for question number 6. Okay, it is quite easy, guys. So what is given in the question is angular displacement versus time graph. I have already marked it for you. You just have to fill it up. So the object rotates at 3 radian per second for 4 seconds, and then rapidly decelerate and then remain stationary for 6 seconds, and then reverse and accelerate uniformly to the original position after 15 and after a total time of 15. So first 4 second it is rotating at 3 meters, so at 4 second it will be at 12, right? So and it is moving with the constant angular velocity, so it will be a straight line joining from 0 to 12, a linear straight line, because angular velocity is constant. It decelerate very rapidly and moves and stays there for next 6 seconds. So next 6 second is the 10th second, so this will be straight. Don't mark it to 0 because it will be at that particular displacement from the initial. Okay, and after next in the next total 15 next 5 second it uniform accelerate in the reverse direction. So it means that it comes back, but this time it will be a curved line like this. Sorry, not like this. This will be a curved line because it is uniforming decelerate, yeah, like this. So it will not be a linear line, it will be a curved line like this. Now why not like this? The reason being, it is not accelerating from here. This will be the deceleration, because this will in shorter interval of time less angle is short, but here the shorter interval more angle is short, means it is accelerating, and this will be the case for acceleration. Sorry, this will be the case for deceleration. Here the speed is continuously increasing with respect to time. So this will be the best diagram or the sketch for the angular displacement versus. If you have any doubt, just comment below. Now pause the video for question number 7. This is quite easy. Okay, now for A part, angular acceleration during the first 2 seconds. Now we know that a velocity versus time graph gives us the acceleration. So angular acceleration alpha will be 5 minus 10 divided by 2. This will be minus 5 by 2. This will be minus 2.5 radian per second square, because this is decelerating. So this will be the answer for the A part. Now B part is, through what total angle did the object rotate in 6 seconds? Now we know that angular velocity versus time graph, the area under the curve gives us nothing but the angular displacement. So we can find out, let us say this is A1 and this is A2. So what we can do is we can find out the angle will be the area under the curve. So we can find out total angle is equals to A1 plus A2, which is nothing but half sum of its parallel side, which is 10 plus 5 times perpendicular distance is 2, this plus this will be 4 and this will be 5, 4 into 5. So if you solve this, 15 plus 20, this will be 35 radian. So this will be your answer for the last part. Okay, so I hope for the kinematics of rotational motion is quite clear. You just have to use the Suvet equation in terms of rotational mechanics. Okay, so I hope every question is quite clear. If you have any doubt, just comment below and share with the others. That's the only purpose for making such videos, and it will give me more motivation to complete the series. So thank you for being with me. See you in the next video. Keep learning. Bye bye.